Hey everybody, today you can see the title on the screen. We're going to work our way through simplifying expressions. So I want to make sure that we are good with what we're getting into today. Today we're jumping right back into order of operations. But we're going to do it with some of the stuff that's a little uglier, some of the stuff we've been working on. So today is a culminating day where we put everything together up until this point. Okay, these are challenge problems for you, looking big picture. Best of luck today, okay? Here we go. So to start off, since we are talking order of operations, I want us to take a peek and just kind of go, okay, are we good on some reminders of what we work through when we deal with some Bedmas stuff, different operations? So what I'd like you to do is just quickly work your way through A and B, and we'll see how we match up in the end, okay? Pause the video now. Okay, we're back. So I want to just quickly go through A because I want us to make sure that we're comfortable, at least in terms of that process of how we deal with going through and addressing Bedmas. Is it a methodical step-by-step process, or can we speed up the process a little bit? So let's take a look at A. I'm going to very quickly say that when I recognize my operations on that line, I can see I've got multiply, add, and multiply. We should be good that we have to do the multiply first. But some of us have a tendency to say, well, then I'm going to calculate my 5 times 4 and get 20. And then I'm just going to copy everything out. Well, then I'm going to do my 3 times 7 and then copy everything. And then do my adding. Yes, that is completely correct, and you have followed our proper order of operations. However, I think we can be better. So my advice to you is when you look back in that original expression, we need to recognize that we have multiply and we have add. And as long as we know within Bedmas, with those operations, I have to do adding last. Then really what I end up getting with that green operation, my addition, is it acts like a wall. As long as I don't cross that wall, then I can simplify anything on either side of it. I would love it if we could very quickly say that I can recognize I can do that multiply. As long as I don't touch that add, I can do the multiply on the other side, and we can be a little quicker. Now we can clean it up. We get down to the same thing, and we are good. Okay, let's take a look at B. Same thing. I want to make sure that we are not really methodical. We recognize our operations. You see you've got multiply, multiply, subtract, exponent. And don't forget about that multiply right in there between the 7 and the bracket. If I do not see an operation, it means multiply. Well, you've got a lot of operations to do. If you take my advice from the first problem and we recognize that that subtract now acts like a wall, well, then you can do any operation you want as long as we don't cross the wall. Take a look at the left. Slow and methodical is going to look like this and say, well, 2 times 4 is 8. Then I have my 5. Then my... What I am telling you is, do as many operations as you are comfortable doing. That is, I would hope that on the left side of that subtraction, we could just do all those multiplies. But maybe we don't multiply them in the order they're given. We choose the order that's best to multiply. I would argue for a lot of us, we are good at doubling things in our head. So I would be tempted to leave the 2 out in front. I'm going to do my multiply of 4 times 5 first and get 20, then double it to come in on my 40. I'll pick the order of multiply that's easiest to work with, the one I prefer. Okay, take a look on the right side of that subtraction. Well, this one's a little different. Because we have an exponent and multiply, there is a defined order. We have to do that exponent first. Now, I recognize that a lot of us would be fine to go through and calculate 3 squared and get 9, and then multiply that by 7 in our heads. For where we're going to go today, could I just get you to write down 7 times 9? It's going to seem like a weird thing to us, but trust me, that's going to become a process that you deal with all the time. Deal with your squared, then your multiply. And in a lot of cases, we'll leave the multiply for a bit. Now you're pretty quick to make that calculation, and we can go ahead and subtract, and we get down to negative 23. Okay, us walking through those two examples are going to start to look really familiar when we jump into our algebra. So as we work our way through our algebra today, I want you to make sure that we can reference back to problem A and B. We're going to see that as some things get really ugly today, all we're really working through is A and B, some order of operations. Okay, let's jump into some stuff that looks a little more familiar with what we've been working with. Okay, things just got ugly, and they just got ugly fast. You take a peek at this problem C, and I'm hoping that you can see the similarity with that with problem A. That is, you have something times something plus something times something. So I'm hoping you can see this is A. If we're struggling to see that, I'm going to actually copy out problem A. 5 times 4, notice something times something, plus something times something. So let's just follow the same process we would have done if it was a good old grade 6 Bedmas question. We recognize we have to deal with our multiply first, but we can treat that addition symbol like a wall, just make sure we don't cross it. So I take a work and I go through and I can expand my first set of brackets. This should be feedback to you. Are you comfortable with some of the mechanics we did in the previous 2 days? I can then go ahead and expand my last 2 brackets. Same thing. In the end, let's add them all together. So what I want to do is I want to give you a chance to see if we can get down to the same thing with that expression. Let's use it as a gauge of where we're at. I want you to pause the video now and try it on your own. Go ahead. Okay, we're back. So let's deal with this as a bit of a check. I can expand my first set of brackets to get a 4x squared. I can see on the outside I'm going to get an 8x, and on the inside I'm going to get a 6x, so that is 14x. And then I'm going to get a 3 times 4 is my 12. There's my first set of brackets, my first multiply. I cannot touch that addition, so I'm leaving it there. Now I can go ahead and do the other multiplication. So there's my 3x squared. On the outside, I got a negative 2x, and on the inside, I got a positive 15. So that's going to give me a plus 13 of those x's. And then my negative 10 on the end. You take a peek at that line. That should give you some confirmation how well your expanding binomials has gone. Now we're right back into grade 9. Let's go ahead. Let's collect like terms. You notice you've got 7x squareds and a 27x with a plus 2. So if we got down to that blue solution and it looks just like that, then I think you're doing great. And there's a Bedmas situation, us dealing with different operations. That's all we're doing today, is we're going to jump in and work our way through that stuff. So let's get some more practice. Okay, you see D out in front, and I want you to go ahead and give D a shot. I'm going to be nice, though. I'm going to argue to you. What I want you to do is just give me the first line when simplifying D. Okay, our instructions, simplify. Just give me the first line. We'll stop there. So if you go down a bad path, we won't go too far. Okay, pause the video now. Okay, we're back. Now, why did I say just do the first line? Well, take a look at the very beginning, and please make sure that you did not try to simplify your first term as if there were brackets around the 3x plus 5. There are no brackets there. So when I'm going through to try to recognize what are my operations, my operation is an addition. There's my multiply. So the only thing that's attached to that bracket by multiply is my 5. I then have my subtraction and then my other multiply. I got to make sure I follow Bedmas. So your first line to me should be some discipline. We don't touch the 3x. It's being added. Now I can expand my 5 in. I'm not going to touch that minus. And now I go ahead and I expand my last multiply. So I get my 2x squared with a minus 14 on the outside and a plus 6, so there's a minus 8, and a negative 42 on the end. I think if you got to that line, I think you're doing great. It's wrong, but I think you're doing great. Okay, why is it wrong? I want you to notice something really important with the last term. When we take a look at that last term, that was a 2x plus 6 times an x minus 7. If that had been just numbers, then maybe we just say, hey, that's a 6 times a negative 7. Let's just say we get rid of the variables and just say like the first bracket equals 6, the last bracket equals negative 7. If we were to do that multiply, that red would be negative 42. Can you look back on the green operation that comes before it? It would say that we should be subtracting a negative 42, which means we should be adding it. We got the wrong sign on our 42. Okay, why does that occur? Well, I'm going to go back and I'm going to get rid of all that red and green, and I really want to just jump back into what we had. When we go through and we multiply that binomial times a binomial in the end, that's going to give us a value, an expression. Because the problem says to subtract that expression, we have to make sure that we don't just subtract the first part of it, but we subtract all parts of it. Now, that is a pretty easy thing to forget about. So, my advice to you is that when you see subtraction in between your two terms like that, maybe play it safe for right now. When you calculate that multiply at the end, put brackets around to remind yourself that you have to subtract all parts of it. Why didn't this arise before? Well, because we had addition in between. And so if I'm going to add things, add positives, add negatives, I still get the same sign. But if I subtract positives or subtract negatives, I'm going in the opposite direction. Okay, if we've got that blue line, now this would be my advice to you on the next line. Clean up whatever you can. I can do that 3x plus that 5x. There's nothing I can collect with that negative 20 because I now need to subtract all parts of what's inside those square brackets. So I'm going to subtract my 2x squared. I'm going to subtract a negative 8x. So I'm really going to add it. And then subtract a negative 42. I'm really going to add that. There you go. The rest is just collecting like terms. So you have your negative 2x squared plus a 16x plus a 22. And I would love it if we matched up in the end on that one. So take a peek back at that problem and just notice what was probably your snag. We imagined that we had brackets around the 3x plus 5 when we really didn't. If we recognized that, we were likely okay. However, we had to recognize that subtraction of the last term and make sure that we subtracted all parts. Okay. Other than like one other thing, I think we've covered everything we need to. It's just now a matter to get a lot of practice with it. So let's try another one. Okay, so you can take a look on the screen in front of you, and I want you to give this one a shot on your own. Okay? Start to finish, and we'll see if we match up in the end. Let's pause the video now. Okay, we're back. So, as we talked about in problem 1b, the idea of having like multiple products, that is something times something times something, and you can see that same thing happening in the second term, a -2 times x minus 3 times x minus 4. We get to choose the order in which we multiply that's easiest for us. I'm going to walk through E at the very beginning just so we can see we may make a decision that is fine mathematically, that may end up making things a little more difficult to work with. If I take that original expression and I just say, okay, well, I'm going to expand in my 3. And I choose to do the 3 times 3x plus 1 first. Well, then that's going to create this. And there's 2 issues that might arise. The first one is we may then write x plus 4. And if we just ignore everything else in the line for a moment, I want you to notice that that orange is incorrect. Okay, it's incorrect because that only says that the 3 is being multiplied by the x plus 4 and not the whole 9x plus 3. So one of the mistakes that we end up making is we really need brackets around that whole thing. Now that's mathematically correct. But the second issue that arises, you'll notice that now to fully simplify that first term, you're now going to have to expand our binomials. And by choosing to multiply that 3 into that first binomial, now when you expand, you're going to end up getting numbers the biggest you could work with, the largest. 9x times a plus 4 gives me a 36x, plus another 3 is a 39x. And you'll notice the numbers are manageable, but it didn't necessarily mean that we worked with it in the easiest way possible. So I just want you to highlight what that first term would simplify to. 9x squared plus 39x plus 12. And now what I want to do is I want to try it a different way. So I'm going to get rid of all of that, and I'm going to make a different decision at the very beginning. That rather than going and choosing to multiply in that 3, I'm going to keep the 3 out in front. And so what I'm going to do is I'm going to leave that 3 there, and I'm going to expand my binomials with the smallest numbers possible. Okay, that would get me my 3x squared. My outsides give me a 12, my inside's a 1, so there's 13. And my last's a 4 for my constants. And now when I choose to multiply the 3 into everything, I'm just expanding in a monomial. And I can pretty quickly expand in. And notice we get back to the same thing we got before. So from a strategy standpoint, I think a lot of people find it a lot easier to just keep the monomial out in front and expand it in at the end. That gives you the smallest numbers to work with. Okay, for the sake of optics, I'm just going to get rid of my last line. And I want to go back and just start to simplify my whole last term. Okay. You will also see that there's an added benefit from keeping that monomial out in front. If I choose to keep our minus 2 there and now expand our binomials, x squared, minus 4 of them, minus 3 of them is minus 7. You'll also notice that I'm less likely to make a sign mistake here. Okay, let's go back to the first term. I can now expand in my monomial as we did before, and now at the same time, expand in. What I'm looking to do is to now expand in that -2, and if I expand in the -2, I'm less likely to make a sign mistake. There's my plus 14x and my minus 24 when I've now fully expanded. So by keeping that monomial out in front, I think that actually makes our life easier and allows us to avoid a risk for mistake. Okay, in the end, we can collect like terms. I can put together my x squared terms, put together my single x terms, and now collect my constants, and that should get us down to our final expression. So what did we pick up from E? When we have that triple product, it might be useful. I think it is very beneficial. Leave the monomial out in front and expand it in at the end. Okay, I want to go through one more problem again where we're just getting more practice working through on simplifying some of these expressions. Okay, take a look at F. I would argue to you, I think F is your doozy. I think F has got as much in it as what you would be required to work with. So, same thing as normal. I want you to go through on your own, see if we match up in the end. Okay, I'd like you to pause the video now. Okay, we're back. So we take a look at that first term and we notice we have a triple product again. I'm hoping we followed our advice and left the 8 out in front and now expanded our brackets. So we had a 6a squared. On the outside, we've got an 8a, inside a negative 9a, so that's a negative 1a, and of course, we're not going to write the 1. And now I simplify my constants, and there we go. Now, I take a look at my last term, and I do not have a choice. The only mistake you really could have made here that I think is a meaningful one is if we had expanded in that 7 first. If you look at question 1b, you'll notice this is the exact same expression as what we just started with. When I threw question 1b at you, it was 2 times 4 times 5, a triple product, minus 7 times a power. And we just were reminded, hey, we got to follow Bedmas, which means we have to do the exponent first. But I'm hoping you can see question F is question B. So if we were good with our order of operations and we did not make that mistake by expanding in, then we should have left that negative 7 out in front and expanded our perfect square. So we square the first, multiply them together and double it. So multiply them together gives me 10a. Double it is my 20a, square the last. And now I created a problem that looks an awful lot like the second line from our last one. Okay, we can go ahead and we can expand in our 8. We notice our numbers are getting a little bigger. That's okay. And now when we go and expand in our negative 7, we expand in our negative 7, so we also see that our sign is changing. Well, if I have my 7 times 25, that's like 7 quarters, so that's $1.75. And now we can spend one line just cleaning everything up. Well, a 48a squared minus a 28a squared gives me my 20a squared. I've got my negative 8 and my negative 140, so there's a negative 148a. And now I got to put together a negative 96 and a negative 175. Well, negative 96 is almost 100. So if I put the 100 together with the 175, then that's a 275. But it was 4 less than 100. So I got to take off that 4. And so that's going to give us a negative 271. And there we go. I think if you got down to that solution for F, I think you are doing outstanding. I think that's some great feedback in terms of our comfort level with our more complex expressions. Okay, there's one more problem that I'd like to go through today. And this would be something that would fall into like an application sort of situation. Can you take what we've been working with and can you apply it to a different situation? Let's take a peek. So I'll give you a moment to give the problem on the screen a read, and you can see the labeled diagram at the bottom. So what you need to do is to find a fully simplified expression for the area of that figure. Okay, I want to make sure that we understand the diagram completely. So you will notice that we have these dimensions that are labeled. You will notice that this side all the way to top and bottom is 3a minus b. This side all the way across is 5a plus 3b. All the way up and down, a plus 2b. And this dimension in here, 2a minus b. Okay, I think you've got enough in your background to be able to work your way through this one. So I want to give you a shot at some problem solving. So pause the video and try to give this one a shot on your own. Okay, pause it now. Okay, we're back. So if we were to work through this problem, there's a couple different ways that you could have dealt with it. I'm going to try to do some different colors on our diagram. One of the things that I think we could have done is we could have looked at it and said, well, I'm going to break that shape, that composite figure, that irregular shape, up into regular parts. And so maybe we just like cut right down there and create a box 1 and a box 2. Now they're both rectangles. We can calculate the area of those easily. Of course, for me to do that, I've got both dimensions on box 1, but I need to know that dimension on box 2. Well, I can find that. That's not too bad. Okay, I'm going to erase that because there could have been another way. We could have chosen to chop off on the top here. And we could have had one big box 1 on the bottom and a box 2 on the side. Okay, you'll notice that's going to require a little extra work. Box 1, we have both dimensions, but box 2, we have neither. So we would have to figure out what this dimension was and what that dimension was. A little bit more work. Okay, well, there is another way you could go through with it, and that would be one where, well, if we took a look at the original shape, it could be viewed as if it was one big rectangle that's missing this part, that part was almost like cut out. So we could then calculate the area of the whole rectangle, the outsides, which we know the dimensions for, and then subtract off the box we don't. Well, we know one dimension of the box, 2a minus b, but we don't know that dimension again. So regardless of how we go through to find the area, we're going to have to find a missing dimension. So I'm going to go back and I'm going to tackle it in one particular way. I think we should be able to see that either of the solutions that only require one dimension having to be found are probably easier. I'm going to choose to go through and find what's there as opposed to what's missing. So I'm going to drop in a height there and think of this as box 1 and this is box 2 for my solution. Okay, what I can do then is I can find the area of box 1 because I know that it's length times width, so one dimension times the other dimension. And I could go through and I could simplify that. Well, I'm just going to slide this sideways a little bit so that we could see I could do the same thing to find the area of box 2 right now. I can see that right now it is a 3a minus b, but I don't have that other dimension. So I'm just going to put a little question mark right at the very top. That's what I need to find. Okay, how can I find that dimension? Well, if I just get rid of some of the colors on the diagram, just to make sure that it's a little clearer. I want to get rid of some of these arrows, just so you can really see one key thing. Look along the bottom of the shape. I'm going to put it in orange. We should be good that all the way across on the bottom is 5a plus 3b. Now look on the top of box 1. We know part of the way across is 2a minus b. We don't know what the rest of the way across is. But if you look up at the top, the two orange arrows have to add together to give me my bottom orange arrow. So I could say then that the question mark at the top has to be all the way across the bottom minus the part I know. And you'll notice I made sure to put brackets around that subtracted part to ensure that I subtract all parts of that dimension and not just the first term. Okay, well, if I simplify that orange, then I'm going to have 5a plus 3b, and I need to subtract a 2a and subtract a negative b. I'm really going to add it. I did not need to see that line because I think we could have done that in our head. We could have said 5a minus 2a is a 3a, and we could have said 3b subtract a negative b is a positive 4b. Okay, we found the question mark we were missing. That was the dimension we needed, so I could jump back up now to my area of shape 2 because I now know that I need to take 3a minus b and multiply it by 3a plus 4b. Okay, you can take a look at both parts of my red. There's me finding the area of the parts. Then I put it all together to make my total. If we stumbled a little bit on going through and building the expression for the area, then I think that walkthrough should really help. If we needed that help, now you get a chance to just check your mechanics. So I want you to take another moment to pause the video and see if you can finish off all the mechanics for the rest of the problem. Okay, pause the video now. Okay, we're back. So let's check. We're working our way through area of box 1. I can expand that into my 2a squared. My outsides are 4ab. My insides are a minus ab, so that's a positive 3ab. And then I have a negative 2b squared in the end. Box 2, I can now expand that to my 9a squared. My outsides give me a 12. My insides give me a minus 3. So that is a positive 9 of those ABs. And then I have a minus 4b squared in the end. Okay, from a communication standpoint, I'm just going to put this part in blue. From a communication standpoint, now we'd want to tell our reader that what we're finding is the area of the total. So you'll see that little subscript with the T circled. I would not have to see the green. Like if you wanted to write, so it is 2a squared plus 3ab minus 2b squared plus 9a squared plus 9ab minus 4b squared. I do not have to see that green. I think your readers should be able to infer, they should be able to make that judgment that to find the total, since you've labeled both parts as adding, just go ahead and put them together. So if I look back up at my reds, I've got 2a squareds plus 9a squareds. That's 11a squareds. I've got a 3ab plus a 9ab is a 12ab. And then I have a negative 2b squared and a negative 4b squared. There is a negative 6b squared. I think you should be good to just give me the blue. Awesome. There you go. That would be an example of like an application sort of problem. Us taking our simplifying expressions and being able to use it within a context. Okay, I think you know your job now. Jump in and get some practice and try to make the mechanics of what we did today as automatic as possible. Okay, good luck.